Today, I'm bringing online a brand new industrial computer based on the Raspberry Pi Compute Module 5. This is the Waveshare IPCBOX-CM5-A, a fully passive-cooled, DIN-rail mountable industrial PC designed for 24/7 deployment in factory environments. Let me SSH into it from my workstation and verify everything is working. First, let's run FastFetch to get a complete hardware summary in one screen. Here's what we're working with. Raspberry Pi Compute Module 5 Lite, running at 2.4 GHz with 16 GB of LPDDR4 RAM. The OS is Debian 13 Trixie, with the latest 6.112 kernel optimized for the BCM2712 chip. The aluminum case keeps it cool, and we're already connected via Gigabit Ethernet. Now let's look at storage. The system is currently booting from a 32 GB microSD card, that's MMC BL0, but the real workhorse is NVMe 0 and 1, almost a terabyte of fast NVMe storage connected via PCIe. In the next video, I'll migrate the OS to the NVMe for full speed performance and longer write endurance, perfect for hosting a time series database for industrial monitoring data. Let me check the NVMe details. This is a Pantherize 1 TB M.2 2230 drive. For a development setup, it's fine. For production deployment, I'd consider a Samsung or WD Black drive for better endurance. Engineering trade-offs. Let's benchmark the disk read speed. Six gigabytes per second from RAM cache and 428 megabytes per second from the NVMe itself. Now you might wonder, why not enable PCIe Gen 3 to push it harder? Simple. For industrial monitoring, the bottleneck isn't storage bandwidth, it's reliability. I'd rather have rock-solid Gen 2 stability than chase numbers with experimental settings on a budget drive. Engineering is about choosing the right trade-offs. Let's verify the network interfaces. This device has dual Ethernet, ETH0, a gigabit interface from the Raspberry Pi RP1 chip, and ETH1, a 2.5 gigabit interface from a Realtek controller. Both interfaces operate at the upper OT layer for supervisory data flow. Here's my design decision. ETH0 goes to the lower OT segment, Modbus devices, RS-485 gateways, industrial sensors. I've assigned it a static IP 198.3.58 because industrial protocols need deterministic addressing. You can't have DHCP lease changes breaking your SCADA polling. Gigabit is more than enough. Modbus traffic is bandwidth light by design. ETH1 handles the upper OT segment on 19168.5.75, supervisory traffic, database replication, aggregated data toward the industrial DMZ. From there, a firewall handles communication into IT. This is where the 2.5 gigabit interface pays off. Match the bandwidth to the workload, not to the chip. You'll also notice WLAN 0, and yes, Wi-Fi is actually working, even though I didn't install an external antenna. The integrated PCB antenna picked up a nearby access point. Impressive hardware, but for industrial deployment, I'll disable Wi-Fi entirely. Less attack surface, better IEC 62443 compliance. Less is more. Let me confirm the speed on the lower OT interface. Thousand megabits, full duplex, auto-negotiated. 2 OT segments isolated from IT by firewall. This hub sits at the upper OT layer, exactly where it belongs. And let's check ETH1, the upper OT interface. It supports 2.5 gigabit Ethernet. That's 2500 base T in the supported modes. Currently negotiated at 1 gigabit because the upstream switch is gigabit, but the headroom is there. Same chip, same cable, plug into a faster switch, and you're done. Finally, the critical metric for any 24/7 industrial deployment, thermal management, around 40 degrees Celsius at idle. The passive aluminum case is doing its job. No fans, no moving parts, no failure points. That means dust-proof, silent operation in a factory cabinet. And let me check for any throttling events. Throttled equals 0x0. Zero throttling, zero undervoltage events, zero issues. Clean bill of health. So we've gone from a sealed box to a fully verified industrial computer in just a few minutes. 16 gigabytes of RAM, a 1 terabyte NVMe SSD, dual Ethernet for proper OT network segmentation, and passive cooling, all in a DIN rail mountable enclosure ready for any factory cabinet. Next, I'll migrate the operating system from the micro SD card to NVMe for full speed performance and longer write endurance. After that, we start building the industrial alarm and monitor hub on top of this hardware. Modbus polling workers, an InfluxDB time series database, a Bootstrap web UI with real-time alarm cards, and email plus push notifications. The complete industrial monitoring platform built from the ground up. If you found this useful, follow for the next episode. See you in the next one.